This lesson is titled Integration by Parts. It's actually the second in a series. There's a helpful mnemonic when you're trying to remember integration by parts, what to choose for you. It's you first L-I-A-T-E. I think of it as little insects ate. Like somebody's garden's gone and then just a bunch of little insects ate their garden. L means look for logarithmic functions first. I means look for inverse trig. A, algebraic functions. T, trigonometric functions. And finally, E, exponential functions. Now, this doesn't always work, but a ton of the time, this helps make doing integration by parts easier to identify what you want U to be. All right, so remember our integration by parts formula. In this example, or you could do this as a U-try if you want. If you've been working with these problems in class and you want to try this, that'd be a good idea. We're going to try to find the integral of e to the 2 theta sine of 3 theta d theta. So if we follow little insects 8, there's no logarithms, there's no inverse trig. There is some just straight algebra, and e to the 2 theta falls under that that category. So that's the first thing we come to under Li8, little insects 8. And so we're going to let u equal e to the 2 theta. Then du equals 2 e to the 2 theta d theta. Everything that's left is sine 3 theta d theta. That's our dv. So dv equals sine 3 theta d theta. V then, if we take the antiderivative here, we get V is equal to negative 1/3 cosine 3 theta. Plugging in u times V minus the integral of V du. Just plug all that stuff in. And we get this big long expression, but that's just u times V minus the integral of V du. We can simplify a little bit. The negative 1/3 and the e to the 2 theta we can write as one term. We can write negative 1/3 times 2 as 2/3, and then the negative is a positive here. And now we're trying to integrate e to the 2 theta cosine 3 theta. Well, it's not that different from where we started here, but it's different enough that we should probably set up the integration by parts again. So we'll let u equal e to the 2 theta. We've done this before. Du equals 2e to the 2 theta d theta again. This time, though, dv is going to equal the stuff that's left, which in this case is cosine 3 theta d theta. And the integral, going the other direction, the antiderivative is v equals 1/3 sine 3 theta. So we go ahead and replace again. So here, all the way to the 2/3 is the same, and then we open up a parenthesis or a bracket here, and we try to do uv minus the integral of v du. And that's all just plugged in. Clean up a little bit here. There's not much we can clean up. The 2 and then 1/3 can pass through, so I got negative 2/3. And I've got this integral again of e to the 2 theta sine 3 theta. Notice this integral right here is exactly the integral I started with. So I need to get this out of this set of parentheses and get it to the other side. So we're going to end up distributing this 2/3 into both terms. So 2/3 times e to the 2 theta over 3 is 2e to the 2 theta over 9. 2/3 times 2/3 here is where we get the negative 4/3. So negative 4/9. I've got negative 4/9 of these things. I'm going to add those to the other side. I'm going to take that to the next screen. So this thing right here is equal to all this. I'm going to take this 4/9 to the other side. So I've got 9/9 of these plus 4/9 of these is 13/9 of these. And I'm trying to solve for this. This is what I want to know what it equals. So I'm going to multiply both sides by 9/13. Actually, we've factored out an e to the 2 theta. And here's our multiplying by 9/13. 9 and 3 reduces. Gives me 3 over 13. E to the 2 theta times the quantity 2/3 sine 3 theta minus cosine 3 theta. So this thing we were trying to integrate at the beginning, comes down to this. It was a lot wider and longer along the way, but we were able to whittle it down to this one expression. Never, 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 never forget the plus c. What did we do here? Well, we just distributed the 3, and we also threw in the plus c. Why do we distribute the 3? Well, it gets rid of the 2/3 is the only reason. You don't have to do that. That's more of a personal preference in this case. But the plus c is not a personal preference. We have to have that, at least in our final answer, if we're not carrying it all the way along. Here's one for you to try. You've got the integral of 3t e to the 2t. Okay. When I did this, I let u equal 3t. So du is 3 dt. Then dv has to be everything that's left, which is e to the 2t dt. The antiderivative of dv is v. The antiderivative of e to the 2t is 1/2 e to the 2t. So we'll plug that in the formula. This is u times v minus the integral of v dt, already multiplied together. This 3/2 can pass through as a multiplier, and now I'm doing the integral of e to the 2t. The integral of e to the 2t is 1/2 e to the 2t. If we take the derivative of e to the 2t times 1/2, we would get this e to the 2t back. So that's a good derivative. And we're probably going to combine here and make this 3/4. Yeah, we did. So we have minus 3/4. We're done here. How'd you do? That's our learning target for today. I'll see you in class.